Oh, then yeah.
Okay, then that part.
Just like I said, there's so many cars in the parking lot right now.
But how do you get to that car?
Which one's C?
Huh?
How do you get to that car?
No, lift your finger.
A bunch of people didn't walk their cars.
Keep it the same. You have to get keys or something to start it though.
Do these ones, guys.
Alright, which shark fight questions do we want to see you go over? Have questions about?
If you're waiting for something in the summer. You can put up 2 fingers.
Looks like 2, 3, and 4. So we'll do those 6, 7, 4. Okay. Number 2, we haven't talked about this type of domain and range, but using your domain and range knowledge, domain is your x values. So looking at your x values, this would be -3, -1, 0, and 2. Okay. Yes. It couldn't be the last one because that would have to be lines, connecting lines.
Well, what even is that?
That's the same thing as this.
Oh, those are the infinity signs. I was like, wait, what did you just draw?
Okay. Number 3, which of the following represents the verbal expression 3 times the quantity of a number and 4? So 3 times these two things would go together. So be
What is quantity?
indices. Really, all of it.
So like total.
Yeah.
So addition.
Not necessarily addition. It doesn't necessarily mean addition. It's just you're using parentheses. You're using parentheses. It's the quantity of. It's another parenthesis phrase.
I thought we were just. I thought it meant something. I forgot. Me and Sydney were going through like product. It's multiplication. Like that word wasn't quotient. So we were like, what could it be?
For this one, you have to multiply it back out. So using box method, FOIL, double distributive, whichever one. 2x times 3x would be 6x squared, and then we have 2x minus 2, so negative 4x, negative 1 times 3x is negative 3x, and negative 1 times negative 2 is positive 2. And then combine like terms. So 6x squared minus 7x plus 2. You could have put the original and that final into Desmos or your calculator and they would overlap. Or you could factor your final answer using a equals 1 and you should get those 2 factors. So you could check that either way. Questions on any of those? Look at the notes on your desk. You may want to take out your simplifying radicals notes to help you with what we do today also. So today we're going to talk about rational exponents, which is exactly what it sounds like, fraction exponents that can be converted to radicals. So in this we have some a to the 1 over n. The nth root of a, this would be the same thing as the index is n, and underneath the radical is a. Sometimes you'll have improper fractions or just fractions with something that's not 1. Okay. And this can really be written one of 2 ways. the first most common way would be whatever the denominator is still your index. And then you would raise that to the n power.
Is that an N?
Or you may see it like the index is the same, but all of this is being raised to the n, so either or. You end up getting the same answer, or both, so it doesn't really matter. And first we're just going to convert, we have a bunch of terms in exponential form, and we're going to convert it to radical form, and then we're going to do the opposite, and then we're going to simplify. So if I had something like number 1, whatever the denominator is, that's my number index. So this would be the 4th root of x. Questions there? For number 2, since all of this is in parentheses, everything here would get put underneath the square root. You can put the 2 outside if you want. If 15 could be broken down so that we could simplify it more, we would do that, but 15's factors are 5 and 3, not a pair, so nothing will come out. This is as simplified as this gets. 3, however, we could simplify. How would I write this in radical form? The cube root of 24. And then we have to use our simplifying radical rules to simplify this. So let's do perfect cubes. What's the highest perfect cube that goes into 24? That we could divide 24 by. 8. And it's okay. 8 times what would give us 24? 3. The cube root of 8 is what? 2. So this would be 2 times the cube root of 3. And just like with our radicals, we could put that into the calculator, find the decimal, and see if it matches. We could do the same thing here. Do that. So if I do 24 to the 1/3 power, and what was our answer? 2 times the cube root of 3. We get the same thing. 18. Do you have any questions so far?
No.
In number 4, how would I write this in radical form? The cube root of 7 squared. The cube root of 7 squared, yes.
Which simplifies the cube root of 49. But I don't.
No. You could try breaking it down, but again, its factors are 7 and 7, which are prime, and there's nothing else that would go into it. You don't have to prove it. So that would be as simplified as possible. But in number 5, anytime you have improper fractions, you want to split this up. 2 goes into 7 how many times? 3. So that would be 2 times 3 is 6. I'm going to put k to the 6 over 2, and whatever's left. And then I'm going to simplify. This will become k to the 3rd. And then I could rewrite this in radical form, which would be what?
Okay, I don't know how to say it, but it's the square root of k.
Okay, there we go.
So circles have.
Okay. Yes.
How did it become a k to the 3rd power?
Here, if we divide these, we get 3.
Like, why did you do k one return?
So this was 7. We had to split it up. Other questions on that one before we try some others? Let's do another one like that, but with numbers. Number 6, we have an improper fraction. 4 goes into 5 how many times? Once. So that would just be 3 to the 4 over 4 with 1 left over. 3 to the 4 over 4 was simplified to just 1. That would be 1, so 3 to the first, so just 3. And then how would I write this in radical form?
I can never say it correctly.
The fourth root of 3. And
so much.
because I can't take the actual fourth root of 3, it's not a perfect fourth root. That stays the same.
Why is it force?
Because of the fraction. Whatever that denominator is becomes your root, your index. Alright, let's do 7. How would I rewrite that in radical form?
The fourth root of parentheses AB third power.
And then we have to multiply all of our exponents, all of the 3's. So that would become, I'm going to actually write that over here. The fourth root of a to the third, b to the third.
That's the answer.
That is the answer. 4 doesn't go into 3, so that is as simplified as possible. Let's jump to 9. How would I write that in radical form?
Good question.
Square
root of 7 parentheses 12 doubles.
Is all of this going underneath the square root?
Yes, you do it.
No, it's just a parentheses.
Just the parentheses. And then from there, we have to see if we can simplify the square root of 12.
The 7's going to the big number.
It'll
go into 3 and 4. And that's
It would be that. Hold on one second. Say that again.
Would it be a big number or is it a small one?
It's a number being multiplied. It's not an index.
Okay. An index, that's what it's called. There it is.
It would be 3 and 4. W doesn't have anything else, so that's going to stay inside. The square root of 4 is 2. So then my final answer would be 14 root 2W, or 14 times the square root of 2W. 3W, sorry.
Why isn't it index 2?
You could put the 2.
Oh, so it's just there.
It's just there. It's assumed to be 2.
Okay.
Other questions there? The board is messing up on this side, but it's the same answer.
Oh.
Okay. In the bottom section, you're now doing the opposite. Now you have radical form, you want to go back to exponential form. So think about your index. That's going to be your denominator of your fraction. If you have any exponents, change that. How would we write 10?
16 to the power of 1.
16 to the power of 1. You can put this in parentheses, but you don't really need it. Right. What about 11?
X squared to the power of
Like this?
I believe so.
Or missing
Parentheses?
We need parentheses. To say that both of these are in the 1/2. Number 12.
8W to the power of 4, but 8W is in parentheses.
If I could simplify 8 to the 1/4, I would do that, but in this case I can't. We'll do some more when we come back from Yes.
In 12, how did you make 1/4?
The index, whatever that is, we make that the denominator.
And then we just put a 1 as a...
Unless you see an X on it. Okay. I'm trying to think of another rewrite this in exponential form?
Yeah.
14 would be similar. 15. How would you write that?
300 parentheses power 7 over 3.
So
What if you
I'm
want
gonna backtrack that. So you could do it just like that. This wouldn't be 1/7, it would be 1/2. But raised to the 7th power, which would give you 7 powers. So you could just go straight into the 7/2, or you could separate it, put the 1/2 first, and then multiply it. Either one. Let's do 17. Okay, right now in exponential form. What is our index out here? 2. So all of this is going to be to the what power? Not second, but as a fraction. 1/2. So it would be 10 to the 5th, a to the 3rd, b all to the 1/2. And if I was simplifying, I would keep going, but I'm going to leave that one as is. We're going to actually simplify the next page. Do we have any questions on how to convert radical to exponential and vice versa? So with these, some of them are already going to be in exponential form. If they are, then that's great. If they're not, you want to put them in exponential form. And then use your exponent rules, because we know all of those, the 0, the negative, multiplying product, quotient, power for power, those rules. Simplify that, write our final answer as radical form, and then simplify it again if needed. So in this one, we are multiplying like base. It's already in exponential form. We're multiplying like basis. What are we doing with the exponents? Adding them. So they have the same common denominator, so I can just add the fractions. What would that be? X to the power of 5/3. Then I can rewrite that in radical form. First, this is an improper fraction, so I'm going to split it. 3 goes into 5 how many times? 1, so that would be x to the 3 over 3 with how much left over? 2. So to simplify that, the 3 over 3 would just be 1, so x to the first. And then how would I write this in radical form?
Cube root of x.
Cube root of x to the power of 2. You can put that in parentheses. You don't need it in parentheses. Do you have any questions there? Bless you. Let's do 20 just because we have to change the fractions for that one. So again, we are multiplying like basis, so we're going to add the exponents, but our exponents aren't, denominators aren't the same. So I can multiply both of these by 2 to change it. So we have p to the 1/4 plus 5/4. What would our new fraction be? What do you multiply with 3 and 2? Oh, yeah, sorry. P to the 7/4. And then just like this, we can split it. How would we split it?
The second goes into 4 ones, so then that's 1p, and then 3/4 remains, so it's going to be cube root, 4 root p. I don't know how
To the fourth root of,
the 4th root of p to the 3rd.
yes. So this would just be p. This would be the fourth root of p cubed. Pretend that's a p. I just cut off the plate. Do you have any questions on that one?
Why do we have 5 by 2?
It could have multiplied it by something else, but 2 times 2 would give me 4.
Common denominator.
Where am I going to use this in the real world?
I will
Think you
look
don't
that
have
up
math,
really
you want
to be a. So this specifically, I'll look that up. I don't know. I would say something engineering wise. Alright, let's try 21. We are dividing like bases. What are we doing with the exponent? Subtracting, and we have to get a common denominator, so I'm going to multiply both of these by 2. So we have m to the 10 fourths, yeah, minus 7 fourths. What would our new exponent be? M to the 3 fourths. And then how would I write that in radical form? Fourth root of m to the power of 3. We are raising a power to another power. What are we doing with the exponents? Multiplying. So that would be a to what power? 5, 6. And then we could go straight in and write that as in radical form. How would we write that? 6 root of a to the power of 5. Yes. Questions so far? We're going to do that same thing with 23, but we have numbers, so we may have to simplify at the end. So we have 32 to what power? 1/4. And if I wrote that in radical form, that would be 4th root of 32. Now, we haven't talked about forms, but there are perfect 4th roots. I don't know how to say that. In your calculator, I want you to do 1 to the 4th, 2 to the 4th, 3 to the 4th, and find one of those that we could divide 32 by. Yes.
I think it's got to split 32 into 2, and that's
16, yes, because that's what to the 4th? 2, right. So that would be 16, the 4th root of 16, and the 4th root of 2, and the 4th root of 16 is 2, because 2 to the 4th is 16. If you wanted to check this, you can do it in your calculator, you can do it in Desmos. In your calculator, you have to change it though. So you have to type in 4 first, and then go to math, and then go to 5 instead of 4, and it makes that your index, and then you have to go back to the front and add your number. Except I was supposed to put in the original verse, which was... And we see that they are the same, even though they look nothing alike. Any questions on that one before we do some more?
Before the test, when we're gonna have a review for this.
We will have a review day and then just a test day.
So the test gonna be like every single one of these units, like all
Unit
one.
9 and 10. We're only testing those two. We are still going to review 11 and 12 just so that you have it for future knowledge if you have to take the final, but we're not testing those two.
Are we gonna have a quiz beforehand, or just?
The quizzes are out practice. What did you say? Because I have to change the unit. Oh, I did that already.
Like the units also.
Let's say about 5 questions per objective, but 10.1 has more than 5. I know that much. Because it's graphing, quadratic, and exponentials. Let's try 24.
So multiply your exponents. Each thing gets multiplied. So well,
Wow.
work on it again. So 8 to the 2/3 and x squared. If you multiply them, what would that new exponent be? 4 over 3.
Wait, what are we multiplying them with again?
2/3 and 2. And then I could rewrite this all under the cube root since they both have the same denominator. And this would be 8 squared and x to the 4th. Right now the x can be simplified, but the 8 can't. However, if I change this to 64, 64 is a perfect cube. There we go. I was going to say square.
16.
So think of the perfect, the cube root of 64 is,
I thought it was 8.
so what is the cube root of 64? 4. And then if I didn't split this, but if I did split this, 3 goes in 4 how many times? 1. So how much left over? 1. So that would be 4x times the cube root of x. Okay. 25, 26, 27, and 28 all have a negative in front. It just looks like a longer fraction mark. So we'll do a couple of these. Starting with 25. Think about your negative exponent rule. What does that tell you to do? Yes. How? Flip it. So that would be 1 over 100 to the 1/2. And then, how would I write that in radical form?
Wait, if you drop it, make it the entire stay on the top.
It's already in the numerator.
Oh, okay. I see what you did there.
So how would I write this in radical form? Parentheses around. I mean, you can. You don't need them. What did you say, Kate?
I was just wondering if people want to flip it by 100 to the power of 1/2, but I don't think that's possible.
So don't think about the exponent as something like that, but change it to a radical. What radical would that be?
1 over the root of 100.
1 over the square root of 100, which would be 1 over 10. So it looked more complex because of the negative, and then once we figured out, okay, this is how the negative part works, the radical part works the same, and then just do that.
So sorry about
I'll let you guys choose. Let's not do 28, but 26 or 27, which of those two? So for 26, we have like bases. We're multiplying. We're doing what with the exponents? Adding, but in this case, adding a negative or just subtracting. So that would be 16 to what power?
To the 1/3.
How would I write that in radical form?
3 to the power of
Cube root
cube root of 16.
there we go. And then find a perfect cube that goes into 16. 4 is a perfect square, but not a perfect cube.
2 to the 3rd.
8. So the cube root of 8 times the cube root of 2, and the cube root of 8 is 2. Any questions so far?
I don't understand the like when we find the cube roots.
Like this part?
Yeah.
So you have to know your perfect cubes. 1, 8, 6, 27, 64, there we go. And divide each one by those numbers to see which one gives you a whole number. So 16 divided by 1 is obviously 16. 16 divided by 8, that would work. 16 can't be divided by 27. So it would have to be 8.
But like, why don't we, so like, when we do it, and we get, I don't know how to question it. Okay. But like, if it was like 2 to the 3rd, and we got 8, why don't we put 8? Why did it like that?
We did for 8. And then we took the cube root of 8.
I don't know how to like, put it in question, you know?
You were thinking what number, you jumped this up. I feel like. But rethink about how you want to phrase your question and then ask that. Okay. Alright, in 29 through 34, it's now switched to, it gives you radical form. So we're going to convert it back to exponential form, use our exponent rules, convert it back to radical form, and simplify if needed. So it's added an extra step. How would I write the cube root of b in exponential form?
B over B power of 1/3.
B to the power of 1/3. What about the square root of b?
No.
Make it
4/3.
someone said something b to the 1/2. And then if we are multiplying like bases, we're adding those exponents. We're going to have to change both. Multiply this one by 3, this one by 2. Add them together. Actually, I'll just rewrite it first. So that our new exponent would be b to the 5/6. Multiply just these, but you're multiplying like bases, so you have to add the exponents. You would only multiply if they were raising a power to a power. And then how would I write this in radical form?
I got this. I don't know how to say it. 6 to the 6 root to B5.
6 root
Of B5.
b to the 5th. There we go. Do we have any questions there?
6 root of it's just the wording in this.
It's a lot. That's why I'm stumbling up here. Let's do. We'll do 30 and 32. Any others you guys want to see, and then you guys want to do practice. All right. Rewrite the fourth root of r to the third in exponential form.
R to the 3/4.
Yes. What about the square root of r?
R to 1/2.
Again, we are multiplying like basis, so add the exponents, change the 1/2.
2/4.
Our new exponent of r,
5 to the 8. 5 to the 4.
don't actually add the 4s.
Oh, okay. We need to keep them like.
I think that's going to end up being
Yeah,
r
keep them
to
like.
the fourth root r. Yeah. So this would separate into the fourth, r to the 4/4 and r to the 1/4, which would give us r times the fourth root of r. It's a mouthful. Did you figure out your questions already? Not yet. Okay.
I did. I
What did
kind
you
of
do with the other R?
Which one?
Like, in one of the equations, like in that box, there's one R, but there's like not a second.
So this became r to the first, and this is this.
So, like, when we get like a perfect root of like say like 216 or whatever, like a perfect cube or whatever.
Perfect cube, 216. Okay.
Yeah. Do you make it like? Why don't we put it as 216 and then think like why does it have to be like the number? I don't know how to explain.
I don't think. 216 will give us a whole number. But if I type in, so we had 16. No? Which is not. So we have to break it into something that is. So if you're thinking of your factors of 16, are what?
Huh?
What are your factors of 16?
16,
Okay.
2 and 8.
4 and 4.
Yeah.
So of those, 1 and 16, we already tried 16, that gives us a decimal. 1 would just be 1, so that doesn't work. Then we can think of, okay, our 8 or 2, a perfect cube. 8 works, 2 doesn't. So we're just trying to break it down into a simpler perfect cube.
So we would put 6 in instead of 216 because it's simple.
Yes.
Okay, that makes sense.
Okay. 32. Rewrite this into exponential form. How would I rewrite the square root of 7 cubed?
7 1/3. Wait.
7
7 and 3/2. It's a square root, so the 2 has to be our denominator, but it's being raised to the third power.
How do you know it's a square root?
It is a square root. That's all I can say. Alright, what about the square root of 7?
7 1/2.
7 to the 1/2.
Got it that time.
We are dividing like basis, so we're doing what with the exponents?
Addition, subtraction.
And that's just root 2 over 2, which is 1. Which just means that the
The answer is just 7. Because 3 minus 1 will be 2. 2 over 2 is 1. This one I am going to put in the calculator just so you can see that it works. Square root. No?
I heard that.
Square root of 7 to the third over square root of 7. And we got that. Good job. Yes.
When do we get the 1/2? I don't really understand that.
The square root is the same thing as 1/2. This and this are the same thing. If I were to put those both in the calculator, you did the same thing. Other questions? Any other questions that we want to see you go over? guys have a Delta Math on this that's due Friday. Delta Math on simplifying radicals that's due Friday. Your curve of best fit. I have to point out the here. I think that page was wrong. I want to say that is also due Friday. So make sure you're working on those. So past Delta Math, this week's Delta Math, Tuesday's test math packets, 8 through 14, or JLabs. If you want a Unit 10 practice quiz, they're up here. Unit 9 I still have if you want that. If you're working on something, use the time box.
I don't have to put my stuff away.